All right, now we are done with the calculation aspect of our design. Let's go to our drawing now. Let's go to our software to do the diagram and the drawing and the operation sequence of the design. Okay. So if you have any question with this, you can put it on the comment section. All right. So let's go to our design and drawing also. All right. Let's do the structural. No, let's first of all and do our structural work. There's our pole. All right. Now this is our structural work. This particular software does not have enough tools for us to do the pole erection, for us to design our pole, our construction work. Okay. All right. Now let me walk you through how you do your structural work. This is my fitting. This is my two fittings. Like I told you, we are using two fittings for each pole. All right. Remember that you're going to do your earthing and bounding. You're going to do your earth continuity to earth the whole of the pole. And this is your earthing supply. Okay. Among your cable size, you're going to rate them to, your cabling routing. You're going to include, there is going to be 70 mm. Remember that our calculation, we arrive at using 70 mm for our main supply. So it's going to be 70 by 4 core. All right, 70 mm squared by 5 cores. Sorry, 5 cores. 1, 2, 3, 4 is your main supply. Then this one is your earthing. Okay, so you're going to use 5 core. One is for your earthing system to earth the whole of the pole. All right. Remember, the total number of poles we recover was 20 poles, but we are using this one for illustration sake. Okay, this is what we here the limited. We have a limited constraint for space factor here, so we're going to display only 5. Okay, now each of the fittings from our calculation, we recovered 500. Okay, we are giving 550 watt for each fitting, but each pole is going to be fitting two fittings. Okay, then another thing again, remember that your connection method is going to be such that each of these is going to come on parallel form, coming back to this chamber. I use this one to represent your connection chamber, your termination chamber, your terminal block area. Okay, so this MCB is going to be two pole. All right, we're going to use two pole. So I use one pole because two pole cannot accommodate here. So we're going to use two pole like this. All right, these two pole, the connection method is that one of these will come parallel using this cable rating. We are using 1.5 mm square by 3 core auto flex type, auto type cable, auto flex cable. Now, auto flex is such that it's flexible in service so that you enable you pass bendable areas and is flexible in service. That is why we used auto flex. And the content, the number of cable parallel inside the auto flex, cable flex is because we are using 4 as 3 rather. One is neutral, the other one is live. So they are coming on parallel from here. From here, this cable will pass from here, passing through here and come to this chamber. Let me put the chamber. Okay, another one too will pass through here and come to this chamber, making 2 runs. One of the run pass here, another run pass from here. Then termination process is going to be 2 of these, one brand mesh together and terminate to the MC, one of these pole. Then the neutral of this and neutral of this will come parallel to and terminate here. Then feeding from here to this one is going to be such that line 1 feed pole 1, line 2 feed pole 2, line 3 feed pole 3, and they come again, line 1 again take this one, line 2 again take this one. That is how you balance the load. Okay. All right, so let's go to our schematic so that we'll do the connection there. So in your design, you're going to generate a lot of design, a lot of drawings, okay, that will make up the entire system drawing. So this particular one is for our structural work, our construction drawing. So you're going to do your pole, erect your pole in one of the drawing and show the structural view of the pole. All right, like I said, this particular software does not have these fittings. Okay, and it does not have pole. I would have erect them and put them according to the pictorial view of the installation at the site. All right. Okay, so I also show this cable here. I use the new color code like we studied in the previous time. Okay, you are going to use your new color code. The cable, take note again, this is going to be 70 square by 5 core. 5 core because we are including earthing system, the earthing continuity. Okay, all right. So let's go to our schematic. Let's minimize and go to schematic. All right, this is our schematic page. All right, like as the end user demanded, that is going to be incorporated with photo cell. So this is my photo cell. This is the symbol of my photo cell for this particular software. Okay, now this is the schematic. This is one pole, pole 1, pole 2, pole 3. I have 6 pole here. This one represent one of the pole. This one represent another pole, and so on till 6 numbers. Remember, we have 20 numbers. Okay, so the termination, like I said, each of these fittings, each of them, they are parallel, they are coming parallel to the chamber of the termination chamber of the pole where you have this breaker. All right, the termination chamber is the terminal block where you will have to insert this MCB. You create a cable ray. That chamber will include your cable ray where you insert this cable. And during maintenance, that is where you open to isolate power while working here. Okay, all right. The reason why each of them should come on parallel is because in some cases, this one should have, if this one is further increased to another, maybe for example, this one is rated 1000 watt, this one is also 1000 watt. In that case, the breakers should be separated. They should have separate breakers. Okay, because some cases when this one develop a fault, this one will trip, so both of them will be blackout instead of this one tripping and leave this one. So if the rating of this power of this fitting further increase to 1000 watt per each fitting, so in that case this breaker should be two pole, different individual separate pole. So one pole serve one pole serve one. But because they are 250 watt, making 500 watt, we can afford to use one pole to protect the two, then use the other pole for the neutral. As you can see, X1, X1, they are the live conductor feeding the fitting. The two X1 on parallel come to this chamber and enter the breaker, one pole, the live pole. Then X2, X2, they are the neutral. They are also linking together here and they feed the neutral pole. So let's feed them from our supply here. All right, we're going to do them according to our load balance. This one we take from line 1. This one I'm going to take from line 2. This one I'm going to take from line 3. Then we start again. This one take from line 1. This one take from line 2. Then this one take from line 3. That is 6. So each of the phase serve 2 here. All right. Then their neutral we also go according to respectively feed their neutral. There is one more thing I want to draw your attention to. Let's go back to our structural drawing. Let's go back to our structural drawing. Let me draw your attention to something. All right, now remember that this our main supplies, this our the main circuit is coming to this chamber. As you draw your cable during your cable routing, you are going to route it in such a way that these cable branches here, they're going to be a pipe. You're going to pass a pipe across the whole of this place, and you're going to have the branch pipe. Apart from this pipe going here, there's going to be another branch pipe from each pole to jam this one. Okay, so this cable now passes inside and come to this chamber and come back again and continues. Enter this chamber and comes out and continue again. That is how you pass to the end of your cable routing. All right. Okay, so that is what I want us to understand. Then come back to the second one, the schematic. All right. Now let's continue. We are done with our termination process. Okay. Now we are going to design the circuit because we are told to include a photo cell. Remember that this cable we are using a 1.5 mm square by 3 core auto flex. Why this one is armored cable? This one is not armored cable, this one is auto flex. We call it auto flex because the flexibility in service is what we need so that it can easily go to pole with a flexible routing. All right, so this is flexible, this is armored. All right, okay. Take away this so that I can have space. So let's design a control circuit because according to the demand, we are going to incorporate photo cell. So this is my photo cell symbol. This is my photo cell symbol. Let's simulate the system so that you see how this one works. Okay. I don't know if it. Okay. Now, okay, it's not powered. Let's power this photo cell and practice how the function goes before we use it to incorporate to the system. Photo cell demand supply. Let's put up the supply. We have to send supply to the photo cell. Okay. I have supply. So let's simulate. Just watch. I have my output here. So this is my common. If I provide the presence of lighting system to this arrow, look at this arrow. That is where the sensing part of it, the receiver and transmitter is. So one of these is going to sense the presence of brightness. Then this other one will now trigger the system to connect the pole, to connect the control contact inside for you to have output here. So let's just simulate by pressing, watch my hand. As I press inside, it's assumed that this other arrow senses the presence of light, then this one the trigger. See, it's composed of electronics component. You don't need to study the composition of this. All right, but what you need to understand is the operation sequence of it. Okay, you don't need to know how it is designed, how the semiconductor is put together to make up the function. That is not our business. What we're interested about is how the operation goes internally. So watch inside. I have this 1, 2, 3 contact, this terminals. This terminals is what is this one is representing. So let me now presume that there's a presence of lighting system here for here to get operated and give me output. So watch my hand. I press there. You see how this one project? This is a common connecting to this. So if I press, there's going to be output. If I press, there's going to be output. So I have my output here. All right. Okay. Now let's further understand the function again. Supposing I have a light here to light up. I want to light up this load using this photo cell. So what I need is that I need to also power this load using this source. So in that case, I have my source here. So I have neutral here. Let me send my neutral to the load already. I have my neutral here to send to the load I want to control. I'll be left with live conductor here. All right. So now let me feed. We have various way of doing this. Let me feed this lamp to my common. I have my light here. Let me feed it to common here. Yeah, I feed that same light, that same supply to my common. I'm going to demand output from here. I need output from here out. So that output is what I will now use to feed my lamp. Okay, so I have supply here to my common terminal. When here is closed, when here is connected, I'm going to have output here because here is connecting to this place. So let's simulate now. Oh, sorry, it's not triggered already. So that is NC. I use NC. Let me put it on NO. I use normally closed contact. So you're going to come to this place. All right. All right. Now let's operate it. Look at it. You see this lamp coming up. So when the presence of lighting system is detected here, here will be triggered to give you the output here. All right. That is how this photo cell operates. So having known the function of this, let's now integrate the function to our system. Okay. All right, remember that in every automatic system, there is going to be an override. All right, that is what regulatory body stipulates, that every automated system, you must have room for override. That override is for event of emergency and for event of maintenance. When carrying out maintenance, you should make allowance for maintenance ability that is flexible in service. You must create room for maintenance access. Okay, isolation method, isolation access. Okay, so let's take away this. All right, because we have photo cell and we have this system, so in that case, we are going to use a contactor so that photo cell controls a contactor to close. All right, this one is what is going to protect the entire system. This is MCB protecting our cable and also protecting our system for short circuit and overload. All right, why this other sub protection devices? This is sub protection devices. This is the main encomer that will protect the entire installation. But these are the sub outgoing protection to protect individual lighting circuit, individual pole. I repeat again, this protective device is protecting individual pole from short circuit and overload. All right. Meanwhile, this one is protecting the entire circuit for short circuit of this and also problem that might arise within here. Okay. All right. Um, let's go. This is my photo cell. So I have my power here. So I have power here already. So because of that, I'm going to introduce another protective device. Okay. I'm going to provide another protective device to protect this circuit, to protect this and protect this, to protect the coil of my contactor and also protect my photo cell from short circuit. Okay, so that is the essence of this particular one. So I'm going to rate it, put it a B, put it the same B, tag it the same B, so that once you close, all of them closes at the same time. All right. So how do we feed this? We are going to also provide a coil for this contactor. Let's provide a coil. So we have a coil here. Okay. All right. I have a neutral. Remember that we're going to provide override. We need override. Okay. So let's finish. Then later we'll create the override. Okay. So we're going to take our supply from here. Let's take our supply from here. Take this breaker down. We feed breaker from there. Then we further now feed our photo cell. We need neutral here. Okay. So, and we have neutral here. We're going to take from here. Oh, just permit me to take this thing up a little bit. We have tight space factor here. So let's see if we can manage it. So let's take this one up a little. Put it back. I'm using thicker cable to show that we are working on power circuit. Then this one smaller cable to show that we are working on control circuit. So this control circuit, we are using thicker, smaller cable. So it's coming, sorry. We are going to feed our MCB from this supply. Take from here. Then we are going to feed the neutral from here. Just pardon here, go this way. If you so choose, you can make this 2 pole MCB. You can choose 2 pole MCB if you so choose. All right. All right. Then next we now feed the output. This output you're going to feed it here for us to activate the contactor. Sorry, I'm going to change the name to K1. This is K1, the contactor. So you're changing the coil to K1 as well. All right, now we are feeding here. We are taking from here again the output of this. We are using it to feed our common. This is our common terminal for the photo cell. Then the output, normally we're using NO. NO is coming now to feed our contactor. When here is activated, here will close and contactor will get energized. So neutral to feed this is what we are going to do now. So bring our neutral from here. All right. Okay, we are done with that. So what we need to do again is to provide um, override. But before override, let's just test the job. Then before we now provide override. So let's see if we can simulate. All right, let's put on this our lighting system now. So let's now assume that there is a brightness, the presence of light, okay, blocking the view of this photo cell. So in that case, here will be activated. Wash my hand. You see the light come up. When this one come up, the light comes up. If you off your hand, it goes off. Close it again, it comes up. Off your hand, it goes off. All right, that is how this one is operated. So we are going to now provide our override. Okay, how do I how do we go? Now you have you have two systems to do that. Your override is to activate this, is to send power to this contactor. That is your override. Okay. Now remember I have power from here to here. That is my common. So what I need is to provide a switch here activating this one. And that switch is going to be um, something of this nature. Okay. Let's just further modify this to create space. Okay. Take this one down a little, take it down. All right. Then bring the switch. All right. S2. Or let's say S1 because we don't have S1 before. So this is our override switch. So we're going to activate our override switch. All right, here is what happened. If this switch is in open state, it's not activated. Let this one work now. Let's simulate. Just hold on. I put on the system, and photocell is what I want to use to activate the function. Let me activate photocell. You can see the light is up. When photocell shut down in the morning, the light goes off. If it closes again, the light comes up. If it shut down, the light goes off. Now, during your maintenance, okay, and you want to test your job at noon because it's not yet night, so it can't come up. So, but you want to test your job, just activate this. The same power here, okay? Deactivate. Even if you activate this and you forgot to shut it down, supposing it was raining heavily and everywhere is a kind of crowded, and you leave it on, and this one fail, because sometimes this one might fail. The function of this is to detect darkness and get activated. So in that case, not just only for night, even if it is raining heavily, this one supposed the light supposed to come up to bright up the walkway, okay, expressway, right? So if this one fail, you can activate this. So if this one is activated and it is raining and is still working, and this one now get activated, both of them can work together. There is no harm. It's the same way. It's not having any short circuit of different potential. It's the same live conductor. It's closing and opening. Just create open circuit and create closed circuit. So both of them can get activated simultaneously. There's no harm. It's just the same live conductor that's closing. Okay. So this is our project for our high walkway. Our, what is the title? Let me see again. Yes, highway lighting project. Okay, there is our dual carriage road lighting project. So I think this is end of our design. So let's simulate once again. By photo cell, you get activated and light comes up. When brightness is present, deactivate, the system shut down. Okay, all right. Then by emergency, you activate this, the same system comes up. Okay, all right. So thank you. Um, let's see if we can. All right, let's screenshot. Okay. Let's simulate and put on by Teams here. Okay, screenshot by. Okay, all right, we are done with this. So more updates are coming, so you can share to your friends and students and electricians. Anybody that see that is you will be of a great benefit to this information, you can send this to the person. All right, thank you.